Well, hello and welcome. In this presentation, I will be looking at unit cost depreciation and how it can be applied using recurrence relationships. Just as a recap, unit cost depreciation can be applied using this recurrence rule. Vn equals V0, my initial value, minus ND. Now, unit cost depreciation is all about how much per unit. Now, a unit may be an hour of lifetime of use, it may be a kilometre, it may be a page. However, what you need to appreciate is there is a linear relationship. Each unit, you see here in blue, will reduce the value of my item by the same amount per unit. Thus, we have a linear relationship or a linear decay. So we're going to go through a couple of examples, but first, just as a summary, unit cost depreciation, say I have an item at cost $201 and it goes down by $3 per unit, then we can say that the recurrence relation, my value of my next term equals the value of my current term minus my value of D. In other words, it's 3. And the rule to derive any value of any term is V0 minus N times D. So we're going to go through an example that actually uses this rule, then a couple of other ones. Okay, we'll look at an example using unit cost depreciation. Now, a $201 hair straightener, just skip the word day, has a working life of 67 days. Use the unit cost depreciation model to determine its value after 30 days of use. Now we're going to assume that after the 67 days, the scrap value is 0. In other words, this hair straightener will just get tossed straight in the bin. We can't sell it on eBay or anything like that. So we need to work out how much does it cost us per day. Well, we can say, well, it's $201. That's the hair straightener's cost. When I purchased it initially, I use it for 67 days, so it's costing me $3 per day. That is my unit cost. So my value of 201 is the initial value, V0, decaying at a rate of $3 per day. So the recurrence rule, Vn equals my initial value, V0 minus N times D. So what's my value after 30 days? It will be 201 minus 30 for 30 days times the $3 per day. And we can just do a little bit of maths and come up with an answer, and I don't think that's all that important. We can just put that into our calculator. 201 minus 90. There you have it. So it's $111. Okay, let's move on to the next example. Now this time, Ocean purchased a bike for $20,000, which is expected to have a useful life of 100,000 kilometres. The bike is anticipated to have a scrap value of $5,000. What is the book value of Ocean's bike after she has ridden or travelled 30,000 kilometres? Now, what I look at here, the initial value, $20,000. And then I need to work out what is my unit cost. Now the unit cost is the cost per kilometre. Well, the bike is effectively going to cost me over its lifetime $20,000 minus $5,000, which I'll recover from the scrap, divided by 100,000. In other words, it's going to cost me 15 cents for every kilometre that I ride it. So if I want to know what its value is after 30,000 kilometres, value after 30,000 will be its initial value minus 30,000 times 0.15 of a dollar. So its value after 30,000 kilometres will be $15,500. And let's move on to the last example. Okay, so I have a $120,000 photocopier, and over its lifetime it's expected to print 1 million copies. Now, I've told you the cost per unit of an individual copy is 10 cents, so it's going to cost 10 cents per page. How many copies have been made before the copier has a book value of $60,000? So, straight up we can say, well, my initial value, V0, is 120,000. My D, or my unit cost, is 10 cents. And I can use the recurrence rule, Vn equals V0 minus N times D. So 60,000. All right. We want to know how long will it take for us to get to 60,000? Well, that equals my initial cost of 120 minus N times 0.1. So N times 0.1. Okay, we just need to rearrange this equation, a little bit of algebra. I won't do that, but just take it from me that the number of copies will be 600,000. So there you have it. 3 fairly quick examples that outline the basics of unit cost depreciation. So until next time, good maths and bye for now.